Hello everyone, my name is Anthony Ramirez and I'm a cloud engineer at Nebulaworks. And today's whiteboard session, we're going to talk about continuous integration, delivery, deployment, and how this aligns with creating higher quality software. So the objectives for today are to describe at a high level what continuous integration, delivery, and deployment are. And I assume that you may be curious about these concepts and you want to adopt them inside of your organization or your development teams to increase the quality of code and to provide developers with more tools and able to create features more quickly. So I'm going to start by talking about continuous integration, which is abbreviated as CI. And I'm going to start by talking about source code management. So there needs to be a strategy in place in order to manage changes to a code base. So with a tool like Git, there's a concept of branches. So with Git, there's typically a mainline branch that is stable, and every time a change or a feature needs to be created, a branch will be created from the mainline, tested, and then merged. So the idea of continuous integration is providing developers confidence in small incremental changes that they're making in order to merge them back into the mainline code base. So one thing that's important to note is that to have features that are consumable and are realistic to implement, it's important to take a large problem and break it down into smaller tasks, or the idea of divide and conquer. And this is important because if a task is small enough, then the developer can finish it, have a feeling of accomplishment with developing their task, and integrate this code back into the mainline at least daily. So continuous integration should encourage developers to merge their code into the mainline code base as frequently as possible, and provide them with feedback loops if their code is broken. So a typical workflow for continuous integration would start with a developer that's developing code on their laptop, and they're working on a feature called feature 1. I'll call it F1. And the first thing that they do is they merge the mainline code base into their feature branch. So if this is the mainline and this is the branch, if we make a feature or a point-in-time snapshot of the mainline here, we call it feature 1, and we can progress with added features or functionality. However, if there's another developer that's working on feature 2, and their feature gets merged back in the mainline code base, feature 1 has now drifted and does not have the changes of feature 2. So the first thing that a developer would do is pull mainline or master. So now feature 1 contains the mainline changes. After this, we have assurance that the code that we wrote functions with the latest code in the main. Next thing we do is run local tests. Once these tests pass, the developer can commit the changes, and a tool like Jenkins, a continuous integration server, is listening for any changes to the code base and will pull the feature 1 branch and run a series of automated tests. So you may be thinking, why is there redundancy in testing? Well, the developer can test locally. However, having an integration server that runs automated tests provides redundancy, as well as maybe catching errors that the developer was unaware of, such as they didn't pull the master branch. So Jenkins or some other automation engine could provide additional tests in order to provide higher confidence in the changes that are being made by the developer. Once this passes, then it's ready to be committed to the mainline or the feature branch. If it fails, the developer should be notified with a feedback loop, notifying them that their change or their feature is broken and they have to fix it. So this creates responsibility or accountability for the developer. So if their change is not functional or does not work, then an automated system will notify them. So there does not need to be any other humans involved here. So creating this feedback loop provides developers faster information so they can resolve an issue or fix some broken code. So then they can merge code back into the mainline more quickly. So at this point, this types of tests could be unit tests or build tests. And once these passed, we know that at least the small piece of code that was added is functional. And next, as we shift over to the right here, we have continuous delivery. So continuous delivery is the ability to test code and package it in a form that it is ready to be deployed. However, we do not mandate that code needs to be deployed at this stage. Continuous delivery just provides us with the confidence that the code can be deployed. So one thing to note is that typically with more complex systems, there needs to be a series of tests that are broader than a unit test or a small piece of code or even one repository. So for example, we might have a multi-tier application such as a presentation layer, logic, and maybe database. So together, this system provides a website. So if we made a small change to the presentation layer, we can test that the functionality works here. However, to do a full system test, we need to see how this change may affect the rest of the layers. And so a series of system, integration, regression, and acceptance testing can be implemented at this stage. And occasionally, there could be tests that can't be automated. Therefore, system tests or quality assurance tests or user acceptance tests would be done here. And the idea of having smaller tasks provides developers the ability to integrate code more frequently. And when we get to the continuous delivery stage, we're working with smaller batches of changes. So we lower risk of deployments because we're testing smaller pieces of code, as well as running a series of tests that involve the entire system. So once the code has been tested and it's fully vetted, there's usually some sort of artifact that's created. This could be a jar file, it could be a binary that's compiled, it could be a Docker image, and so forth. Usually this artifact is placed in an artifact store, such as JFrog, S3, or some other place, and it's ready to be deployed to a production environment. So even if we're able to create these artifacts and have functional systems from small changes, it does not mean that the business is ready to deploy the code, or the product teams have dictated that features to be released are on specific schedules, but that doesn't mean that as the code is being incrementally built, that these system tests or full-on integration tests shouldn't be functional. They should be working regardless of the size of the changes. So for continuous deployment, we want to favor automated deployments, which are scripts or configuration management solutions that provide consistency when we push code to production environments. And one thing I just had mentioned was that deployments are typically dictated by product teams or release cadences that are defined by business objectives. So because code is ready to be deployed does not mean that it will be deployed. However, delivery guarantees that at any point in time or version of the code, it can be deployed. So when we're deploying to an environment, it's important to have consistency. So if we test it in a development or staging environment, it should look identical to the production environment. This reduces friction when moving code from environment to environment, and we can achieve this consistency by using infrastructure as code. Tools such as Terraform or CloudFormation provide that consistency, as well as the ability to version control your infrastructure. So you could treat your infrastructure as you would your software. So these same concepts apply to your infrastructure as code. Another thing to note is that when we deploy software, it's important to have a release strategy. You can achieve this with Git using something called release candidates. And tags. What this does is it marks a specific branch or point in time of the code that is functional, that is ready to be delivered. So having a strategy for releasing is very important, because if you ever need to roll back, you're guaranteed that the code at that specific point in time is functional, and you can always roll back if needed. So at a high level, we described what continuous integration, delivery, and deployment are. And there's a lot more to learn about these concepts, so look at the links in the description for more information. If you enjoyed this video, please like and subscribe to our channel. And if you want more information regarding CI/CD and how to develop strategies for your company or your team, please visit us at nebulaworks.com/#contact us.